The largest and most destructive earthquake on Earth occurs where two tectonic plates collide. Considerable work has been done in seismology to explain the characteristics of the recorded ground motions in earthquakes. Such knowledge is needed to predict ground motions on future earthquakes so that earthquake-resistant structures can be designed. Although earthquakes cause death and destruction, improved understanding of the distribution of melted rocks will help understand where destructive earthquakes are expected to occur. Earthquakes are caused by the sudden release of stress. Along faults in the Earth's crust. The continuous movement of tectonic plates leads to a steady accumulation of pressure in the rock layers on both sides of the fault. Until the stress is large enough that it can be released by sudden movement. The generated seismic energy waves propagate through the ground, and its surface causes earthquakes. The geophysical model of the subduction zone allows to accurately map the location of molten rocks and fluids. Electrical conductivity of phlogopite, fused deposit, and fluid produced in the experiment by researchers matched well. This allowed the researchers to calculate whether molten rocks and fluids are in the subduction zone. When sediments are carried down into the deep earth at a subduction zone, they started out as a thick layer of mud on the seabed. But are then carried into the sinking earth and became part of the sinking slab. When sediments melt, they react with surrounding rocks to form the mineral phlogopite and saline fluid. Melting sediment from the seafloor helps tectonic plates slide over one another without creating major earthquakes. Earthquakes don't occur where the sediments alone melt. The molten rock, salt water, and even phlogopite minerals can help the two plates to slide over each other easily. Without causing a major earthquake. Complex detective work is required to interweave all the little information to have about the processes that occur deep inside the Earth.